Hello, in this video I'm going to describe how a modern computer following the von Neumann architecture actually works. So this is a simplified architecture. So we have the CPU that stands for Central Processing Unit, and within the CPU we have the control unit that is responsible to fetch the instruction, decode the instructions, and execute the instructions. We have the memory that contains the instructions and the data, and we have the input and the output. So the input can be the keyboard and the output can be the screen or printer. So within the memory, we distinguish between the instructions, the program, and the data. And within the CPU, we also have small memory registers. We have the program counter that is that keeps track of the instruction that needs to be executed, and we have the data register that is a small piece of memory that the LAU uses to perform the operations. So let's see how it works. So first we need to fetch the instruction. So the program counter here points to the first instruction, instruction 1. So we fetch that instruction to the control unit. The control unit now decode the instructions, and knowing what it has to do is it can be either load or store instructions. That means that we may need to load data from the memory to the data register, or the other way around. We may need to store data from the data register to the main memory, or it could be an arithmetic and logical operation. And then the program counter points to the next instruction, and we execute the follow, and we do the same over and over again until death. All right, so instructions are just 0 and 1s. So the control unit has to know what it is. So there's a decoder in that unit to route the or to ask for the right operation to be executed. And to write the instructions, we can directly write the machine code, knowing what they are. But as you can imagine, this would be a very tedious task. So we can write a language. We can write with a language that is very close to the machine code instruction sets. We can write what we want to do. And this is the assembly language, and a program called the assembler then translates this language to actual machine code. So here is an example of assembler. So we want to do the addition between two values. So first we need to load the two values we want to add. So we have the LDR, the load instruction, the load operation. So on the first line here, first row, we load into the register number 0 the value that's in memory, and in the register R3 we assume that we have the address in the main memory of the data, the first data we want to add, and we put that into R0. Second row do the same, except that this time we put in R1 the value from the memory that is at the address given by the value that is in the register 4. Then in R0 and R1 we have the two values we want to add, and we can perform the add operation and put the result into the register R2. And finally we can put the result from the register R2 to the main memory at a given address, at an address given in the register R5. Let's take an example. So we assume we have this. So as you can see here in the program section, we have our 4 instructions, and in the data registers, we already have addresses of the components we are going to use in the main memory. So let's start. So first we fetch the first instruction, and we recognize that we need to load into R0 the value that is at in the main memory at the address 000. So let's say that's this one. So we perform now the instruction. So we load that 23 into R0. Let's do this there. Now, on the left hand side, you see that the program counter now is pointing to the next instruction, which is the same instruction, except that this time we load into R1 the value from the main memory that is given, that is stored at the address given by the value in R4, which is 4 here. So for example, it points here, so that's that 45, and then we perform the instruction. We load that 45 into the data registers. Now we have the two values in the data register, so we are able to perform the actual addition. That's the job of the ALU. So as you can see now, the program counter points to the third instruction, and now we know that we can add that 23 to that 45. The result is 68, and we write the result into the register R3, the third register. And now the last instruction is to store that 68, that value that we have in R2, into the main memory at the address given by the value in the register R5. So here this is the address 8. So that means that we can store that 68 into that memory, into that part of the memory in the main memory. And we can imagine that now we're able to print or to display the output on the screen. And that's it.